Imagine a scene in your mind: stars twinkling in space, planets revolving around the sun, and rockets launching into the sky with a burst of flames. Now, imagine all of this happening to the beat of thrilling music. That's the power of science. Physics in particular helps us understand these incredible phenomena. Science visuals and soundtracks aren't just for movies. They can make learning about physics fun and exciting. Picture yourself pushing a heavy box or watching a basketball bounce. These everyday actions are all about force. Forces are all around us, even if we can't always see them. They push, pull, and act upon objects in ways we might not realize. Physics helps us make sense of these actions. It breaks down complex ideas into something we can understand. Forces are like the invisible hands that move everything in the universe. They are fundamental to how things work, from the smallest particles to the biggest galaxies. Let's dive into the basics of force and discover the magic behind everyday motions. Force is a push or a pull. That's it. Easy, right? Think of it this way. When you push a door to open it, you are applying force. When you pull a rope in a game of tug-of-war, you are also applying force. Forces can change the speed and direction of an object. They can make things start moving, stop moving, or change direction. Imagine you are playing soccer. When you kick the ball, your foot applies a force that makes the ball fly through the air. If you push harder, the ball goes faster. If you kick it at an angle, the ball changes direction. Forces are what make things happen. Without them, nothing would move or change. Forces are everywhere, and they can act in different ways. Sometimes they work together to make something happen, and other times they work against each other. For example, if two people push a car from opposite sides with equal force, the car won't move because the forces cancel each other out. Understanding force is like having a superpower. It helps you predict and control the world around you. Gravity is one of the most well-known forces. It's the reason why we don't float away into space. Gravity pulls objects toward each other. The Earth's gravity pulls us toward the ground, which is why we stay grounded. Without gravity, everything would drift aimlessly. Think about when you drop an apple. It falls to the ground because gravity pulls it down. The same force that makes the apple fall also keeps the moon in orbit around the Earth. Gravity acts everywhere in the universe. It's what gives us weight and keeps the planets in their paths around the sun. Gravity is a constant force. No matter where you are on Earth, gravity pulls you toward the center of the planet. That's why when you jump, you always come back down. Even though we can't see it, we feel gravity every moment of our lives. It's a force we rely on to keep our feet on the ground and our world in order. Friction is another important force. It's the resistance that one surface or object encounters when moving over another. Friction is what makes it hard to slide a heavy box across the floor. It's also what stops your bike when you squeeze the brakes. Imagine you are running and suddenly stop. Your feet don't slide endlessly because friction between your shoes and the ground slows you down. Friction acts in the opposite direction of motion, working to slow things down or stop them completely. Without friction, we would slip and slide everywhere. Friction can be both helpful and annoying. It helps cars grip the road so they don't skid out of control. But it can also wear things down, like the soles of your shoes or the tires on a car. Engineers often have to think about friction when designing machines and structures. They find ways to reduce it where it's a problem and increase it where it's needed. Section 5. Applied force, the push that gets things moving. Applied force is exactly what it sounds like. A force that is applied to an object by a person or another object. When you push a shopping cart, you are applying force to it. When you throw a ball, your hand applies force to the ball to set it in motion. Applied force can be seen everywhere in daily life. Take, for example, opening a door. You apply force to the door handle and the door moves. The amount of force you apply can change the speed and direction of the door's movement. If you push harder, the door opens faster. If you push gently, it opens slowly. Understanding applied force helps us control the world around us. It's essential in sports, where athletes apply force to balls, bats, and their own bodies to achieve desired movements. It's also crucial in construction, where workers use tools to apply force to build structures. Knowing how much force to use and in what direction can make a big difference in how effectively tasks are completed. Section 6. Tension, the pull that keeps things together. Tension is the force exerted by a string, rope, or cable when it is pulled tight. Think of a game of tug-of-war. The rope is under tension because both teams are pulling on it. Tension keeps the rope stretched and helps determine which team wins. Tension is present in many places we might not think about. Suspension bridges, for instance, rely on tension in their cables to stay up. The cables are pulled tight, creating a force that supports the weight of the bridge and the vehicles traveling over it. Tension is also at play when you pull a rubber band. The more you stretch it, the greater the tension. In our daily lives, tension is essential for things like hanging clothes on a line or securing loads with ropes. Understanding tension helps in designing and using objects that rely on pulling forces. It's a key concept in engineering and construction, where the stability and safety of structures depend on managing tension forces effectively. Section 7. Newton's 3 laws of motion, simplified. Newton's first law of motion states that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an external force. This is also known as the law of inertia. Imagine a soccer ball on the ground. It won't move until someone kicks it. Once kicked, it will keep rolling until friction or another force stops it. Newton's second law of motion tells us that the force acting on an object is equal to the mass of the object times its acceleration. This means heavier objects need more force to move. If you push a light box and a heavy box with the same force, the light box will move faster because it has less mass. Newton's third law of motion is all about action and reaction. For every action there is an equal and opposite reaction. Think of jumping off a boat. When you push down on the boat, it pushes you up into the air. The boat moves backward while you move forward. These laws help us understand how and why things move. They are the foundation of classical mechanics and are used to design everything from cars to rockets. Knowing these laws allows us to predict the behavior of objects in different situations. Section 8. Real-world applications, rockets, cars, and sports. Rockets are a great example of Newton's third law. When a rocket launches, it expels gas out of its engines. The action of the gas pushing down creates an equal and opposite reaction that propels the rocket upward. This is how rockets overcome the force of gravity to reach space. In cars, all three of Newton's laws can be observed. When a car starts moving, it overcomes inertia. The engine provides the force needed to accelerate, which depends on the car's mass. When brakes are applied, friction slows the car down. Tension forces are at play in the seatbelts, keeping passengers secure. Sports are full of examples of forces at work. In basketball, players apply force to jump, throw, and dribble the ball. Gravity pulls the ball down into the hoop. Friction between the player's shoes and the court floor allows for quick movements and stops. Understanding these forces can help athletes improve their performance and avoid injuries. Section 9. Summary and encouragement to explore more. We've taken an incredible journey through the fascinating world of force in physics. Imagine this. We've learned that force is a push or a pull that can change the speed and direction of an object. Isn't that amazing? We explored different types of forces like gravity, friction, applied force, and tension. Imagine the possibilities. We also delved into Newton's three laws of motion, which explain how and why objects move. Isn't that fascinating? Understanding force helps us make sense of the world around us. It's at play in everything from launching rockets to playing sports. Imagine the impact. By knowing how forces work, we can predict and control the movements of objects, improving our daily lives and advancing technology. Isn't that incredible? But this is just the beginning. Imagine what else is out there. There's so much more to explore in the field of physics. I encourage you to keep learning and asking questions. Isn't that exciting? The more you discover, the more you'll realize the incredible power of science in explaining the wonders of our universe. Imagine the endless possibilities. If you enjoyed this video, don't forget to like and subscribe for more exciting content on physics and beyond.